Next example of related rate, we have a ladder that's leaning against the house. So here's my house. Here's my ladder. And it says that it's a 25-foot ladder. If the base of the ladder is being pulled away from the house at a rate of 2 feet per second, how fast is the top moving down? When the base of the ladder is 15 feet from the wall. Alright, so it looks like we've created this triangle here. We'll get into that in a minute. Let's go ahead and figure out what we're given and what we're trying to find. We're given a couple different things. I'm going to go ahead and label this triangle as X, Y, and Z. And you guys will see that a little bit later why I'm going to choose those. Well, actually, I'll just talk about it now. The X, I'm choosing that because it's horizontal. The Y, I'm choosing that because it's vertical. And the Z just because it's in alphabetical order. So I am going to be given that dx over dt is equal to 2 foot per second. The change in my x with respect to time is 2 foot per second. I am also given that z equals 25. I'm supposed to find the rate at which dy is changing when the base is down here, so that's x. When x is 15. As I said, we had a triangle. Well, this happens to be a right triangle. We're talking about the sides of the right triangle. So hopefully you're able to do step 3 and pick out the formula, which would be Pythagorean theorem. X squared plus y squared equals z squared. I actually know that z is 25. Fourth step, differentiate. Take the derivative of this. So the derivative with respect to time is 2x dx over dt plus 2y dy over dt equals the derivative of any constant is 0. We're finding dy over dt, so I'm going to get dy over dt by itself. I could plug in known values at this time too. I'm just going to go ahead and solve for dy over dt. Dy over dt ends up being negative 2x dx over dt divided by 2y. The 2's actually cancel, and I'm going to go ahead and plug in my known values now. I might have done this a little out of the order that we're used to, but that's okay. X is equal to 15. Dx over dt is 2. And then we're supposed to put this over y. I nowhere can find y, but I know that back in my problem I had Pythagorean theorem. So I have a 15, y, and a 25 in my problem. Well, I know that this is a 15, 20, 25 right triangle, so I know that y is 20. You can also use Pythagorean theorem to solve that. That just takes too much time. So when I simplify dy over dt, I end up getting 3/2, and I'm going to label this as feet per second. I'm not talking about area or volume, so it's just plain old feet per second.